General plane motion. The general plane motion of a rigid body can be described as a combination of translational and rotation. To view these component motion separately, we use a relative motion analysis involving two sets of coordinate axes. Let's look at the relative velocity of 2 points on a rigid body. From relative motion, VA equals to VB plus VA relative to B. Now we choose A and B to be on the same rigid body. The distance between A and B is fixed, so the motion of one with respect to the other is circular. Now we can express the relative velocity as in circular motion. The magnitude is given by VA relative to B equals to omega r. The direction is tangent to the relative motion, that is to say perpendicular to RA relative to B in the direction of the relative motion. So therefore VA relative to B is equal to omega times distance A relative to B. Relative velocity. The velocity of A is the vector sum of the translational portion VB and the rotational portion VA relative to B, which is perpendicular to the line between the 2 points. Every point on the body has the same angular velocity omega. We can also examine the relative acceleration. From relative motion, we have acceleration of A equals to acceleration of B plus acceleration of A relative to B. Once again, we note that particles A and B move in circles with respect to each other. So combining relative motion and circular motion, we get that, where acceleration of A relative to B is equal to the normal acceleration and the tangential acceleration. Relative acceleration. The magnitudes of the relative acceleration components are given by that. Every point on the body has the same alpha and omega. Alpha and omega are absolute quantities, not relative, where alpha is angular acceleration and omega is angular velocity.